In this video, we will be learning about exponent rules. For your use, I have attached a chart of the exponent rules that you will encounter while working in ALEKS. The first rule that we'll talk about is the product rule. In the product rule, our operation is multiplication, so we add our exponents. Given the problem, w raised to the third power times w raised to the negative seventh power, adding our exponent gives us a negative 4, based on our integer rule that opposite signs tell us to subtract and take the sign of the larger number. Having a negative exponent here, we need to convert that to a positive exponent. In order to do that, we will put this in the denominator because it's now in the numerator. So this is the same as w raised to the negative fourth power over 1. So we flip it and we get 1 over w raised to the fourth power. With the quotient rule, we will subtract our exponents. Remember that quotient means division. So whenever you see division, you know you're going to subtract your exponents. So we can start with our constant terms 4 and 2 and divide those to give us 2. From there, we look to make sure our bases are the same. So we have an a raised to the negative ninth power in the numerator. There's no a in the denominator, so we just keep a to the negative ninth. Then we have a b to the negative 2 power in the numerator and a b to the 6th power in the denominator. Remember, we have to subtract our exponents, so that will give us b to the negative 2 minus 6 power. Then we have c to the third power in the numerator and c to the negative 8th power in the denominator. Subtracting those, we'll get c raised to the 3 minus negative 8 power. Again, using our integer rules, remember we have to convert here. We keep the 2 and the a to the negative ninth, b to the negative 2 minus 6 becomes b to the negative 8, and c becomes c to the 11th power. Remember, we have to change our negative exponents to positive. We do that by flipping. So we'll have 2 times 1 over a to the ninth, now that ninth is positive, 1 over b to the 8th times c to the 11th. Multiplying, we'll get 2 times c to the 11th in the numerator, and in the denominator a to the ninth times b to the 8th. With the power of a product rule, we have an exponent raised to an exponent. That tells us that we need to multiply the exponents. What we'll have to do is to distribute this 4 to every exponent inside of the parenthesis. In doing that, multiplying, we'll have x raised to the 3 times 4 power, y raised to the 2 times 4 power, z raised to the 2 times 4 power, times xy. Multiplying the exponents, we'll get x to the 12th times y to the 8th times z to the 8th times our xy. Now we're multiplying this parenthesis times this parenthesis, making our operation multiplication, so we add the exponents. Here, this is understood to be an exponent of 1 and an exponent of 1 because we're not given 1. So x raised to the 12 plus 1 times y raised to the 8 plus 1 times z raised to the 8th, because we only have a z to the 8th here. Adding, we get x to the 13th, y to the 9th, z to the 8th. Negative exponent with quotient. Remember, quotient is division. By the negative exponent with a quotient rule, we make the negative exponent outside of the parenthesis positive by flipping the problem. So what we'll do first is to make the numerator the denominator and the denominator the numerator, giving us p to the negative 4th over 4p squared, all raised to the 3rd power. Then by the quotient rule, we need to subtract our exponents. So Subtracting our exponents, here we have a p in the numerator and a p in the denominator, so that gives us p to the negative 4 minus 2 power over 4, all raised to the third power. Subtracting our exponents, we'll get p to the negative 6, because this is negative 4 plus a negative 2, keeping our 4 in the denominator, all raised to the third power. Now, by the power of a power rule, we must multiply our exponents. So we have p raised to the negative 6 power, which is raised to the third power, giving us p raised to the negative 18th power. And then we have p to the third power, because we had to distribute this 3 to the 4. Now we can multiply, because we know 4 times 4 times 4 gives us 64. Then we need to get rid of our negative exponent in our numerator. In order to do that, we put it in the denominator. So now in our denominator, we'll have 64 times p to the 18th. And in our numerator, we have 1, giving us a final answer of 1 over 64p to the 18th power.